Good evening. My name is Shavina Phillips, and I'm a student at Liberty University, dedicated to advancing inclusive and innovative educational practices. My passion lies in leveraging technology and research-based methodologies to create effective learning environments for diverse student populations, including English as second language learners and visually impaired students. The purpose of this presentation is to explore how multimedia assessments can transform educational experiences of ESL learners and visually impaired students. By leveraging advanced tools such as augmented reality, virtual reality, and gaming based learning, and AI driven assessments, we aim to create more inclusive and effective learning environments. This presentation will demonstrate how the principles of the cognitive theory of multimedia learning can be applied to reduce cognitive load and enhance comprehension for diverse learners. We'll discuss the benefits of these tools, review research findings, and address the challenges of implementing such technologies, especially in under-resourced areas. Ultimately, the goal is to showcase how these strategies can lead to more equitable and engaging educational experiences, helping educators and institutions to meet the diverse needs of their students while advancing accessibility and adaptability in education. Accessibility is vital in ensuring that every student, regardless of their abilities, language barriers, has an equal opportunity to learn and succeed. For ESL learners, accessible tools help bridge language gaps, making content easier to understand and retain. For visually impaired students, accessible technologies such as tactile tools and auditory support off- open the door to learning experience that would otherwise be unavailable. Prioritizing accessibility empowers these learners, fosters inclusivity, and promotes equity in education, ensuring no one is left behind. English as second language learners often face challenges such as language barriers, limited comprehension, and difficulty engaging with traditional instructional methods. Similarly, visually impaired students encounter obstacles related to accessibility and navigating standard learning materials. Both groups benefit significantly from tailored approaches that address their unique needs, leveraging technology and multimedia tools to create engaging, inclusive, and supportive learning environments. Theoretical framework. The cognitive theory of multimedia learning, developed by Richard Mayer, explains how people learn more effectively when information is presented using both visual and verbal modalities. CTML focuses on managing cognitive load, ensuring that learners can process essential information without being overwhelmed. The cognitive theory of multimedia learning outlines key principles to enhance learning efficiency. Modality pairs visuals with narration to improve understanding, while coherence removes distractions to keep learners focused. Signaling uses cues like highlights or arrows to direct attention to critical information, and redundancy avoids repetitive content that can overload the learner. These principles work together to optimize cognitive processing, making multimedia tools more effective and inclusive.
Are you still in traditional investments like stocks or real estate? If you are, you're doing it wrong.
The cognitive theory of multimedia learning can give can guide the effective integration of technology in educational settings to support both ESL and visually impaired students. Here's how CTML principles can be applied using technology. Augmented reality helps ESL learners visualize vocabulary and guides visually impaired students in spatial tasks using tactile and audio feedback. Virtual reality simulates real-world language practice for ESL learners and offers spatial exploration with auditory and haptic signals for visually impaired students. AI provides personalized learning through adaptive tools for ESL learners in accessible formats like text to speech for visually impaired students. Multimodal platforms, tools like Google Translate and Touch Braille Note Touch integrate auditory, tactile, and visual outputs for flexible learning. Integrating technology with CTML principles ensures a more inclusive and effective learning environment. ESL learners benefit from improved language acquisition and comprehension, while visually impaired students gain equitable access to diverse educational resources. This combination fosters engagement, reduces cognitive load, and creates adaptive learning experiences for all students. Interactive technologies are transforming education by creating dynamic and engaging learning experiences tailored to diverse learners. Tools like augmented reality and virtual reality immerse students in hands-on simulated environments, making complex concepts easier to understand. For example, AR can help ESL students visualize vocabulary in context, while virtual reality offers realistic scenarios to practice conversational skills or explore environments that might otherwise be inaccessible. For visually impaired learners, interactive technologies such as tactile feedback devices, screen readers, and audio based learning platforms enhance accessibility. These tools adapt to individual needs, providing personalized feedback and fostering engagement. By integrating interactive technologies into education, we not only enhance comprehension and retention, but also make learning more inclusive and equitable for all students. Augmented reality. Augmented reality, or AR, is a powerful tool for enhancing learning experiences, particularly for ESL students and visually impaired students. For ESL learners, AR brings language concepts to life by overlaying digital visuals and audio in real on the real world. For example, students can point their devices at objects to see and hear the corresponding vocabulary, making language acquisition more engaging and contextual. For visually impaired students, AR can provide auditory and tactile feedback, guiding them through hands on activities like assembling models or navigating new environments. By making abstract concepts tangible and accessible, AR employs both groups of learners to engage deeply with content, fostering comprehension and confidence in ways traditional methods often cannot. Virtual reality, or VR, offers immersive experiences that can significantly enhance education for ESL and visually impaired students. For ESL learners, VR creates real world simulations where they can practice language skills in contexts, such as ordering food at a virtual restaurant or navigating a city. These interactive scenarios build confidence and practical communication skills. For visually impaired students, VR environments can be tailored with auditory cues and haptic feedback, allowing them to explore and interact with virtual spaces safely. For example, VR can simulate environments like science labs or historical landmarks, making them accessible through sound and touch by bridging the gap between theoretical learning and practical application. VR provides inclusive, engaging, and transformative learning experiences for diverse learners. Gaming-based approaches to learning offer an engaging and effective way to support ESL and visually impaired students. For ESL learners, educational games provide opportunities to practice language skills through interactive challenges, vocabulary building activities, and collaborative problem-solving tasks. These games often use scenarios that simulate real-life situations, helping students apply their language skills in meaningful contexts. For visually impaired students, games and auditory cues, tactile feedback, and accessible interfaces enable them to navigate challenges, solve problems, and develop critical thinking skills. By incorporating rewards, progress tracking, and adaptive difficulty levels, gaming-based learning motivates students while catering to their individual needs. This approach not only enhances engagement, but also fosters inclusivity and confidence in diverse learning environments. AI tools and adaptive assessments are revolutionizing education for ESL and visually impaired students by providing personalized and inclusive learning experiences. For ESL learners, AI powered platforms analyze language proficiency and adjust content to match individual skill levels, offering targeted feedback on grammar, pronunciation, and vocabulary. For visually impaired students, AI tools integrate auditory and tactile interfaces, enabling access to content through screen readers, braille devices, or voice activated assistants. Adaptive assessments driven by AI dynamically adjust the difficulty of questions based on a learner's responses, ensuring that challenges remain engaging but not overwhelming. This personalized approach helps educators identify specific areas for improvement while fostering confidence and independence in learners. AI tools and adaptive assessments create pathways for equitable and effective learning, empowering students to achieve their full potential. Ebooks and augmented reality are transformative tools in creating inclusive learning environments for ESL and visually impaired students. For ESL learners, ebooks offer structured, interactive content with features like audio narration, vocabulary support, and translation tools that make language acquisition more accessible and engaging. AR enhances this experience by overlaying digital elements onto the physical world, allowing learners to interact with objects and see vocabulary or concepts come to life in real time. For visually impaired students, ebooks with auditory support and braille displays ensure accessibility, while AR can provide tactile and auditory cues for navigating tasks, such as building models or exploring maps. Together, ebooks and AR complement each other by offering multimodal, interactive learning experiences that cater to diverse needs, fostering comprehension, engagement, and inclusion in educational settings. Research and case studies demonstrate the significant impact of multimedia tools on learning outcomes for ESL and visually impaired students. Studies show that ESL learners using augmented reality improve vocabulary retention and comprehension by engaging with interactive and context-based learning language tools. For example, AR applicants that overlay translations or visual aids onto objects help bridge language gaps. Similarly, visually impaired students benefit from technologies like virtual reality and AI driven tools that integrate auditory, and tactile feedback, improving accessibility and engagement. Case studies also highlight gaming based learning as a powerful tool, fostering collaboration, critical thinking, critical thinking in ESL learners, while tactile and auditory games enhance problem solving for visually impaired students. These findings underscore the effectiveness of multimedia tools in creating inclusive, engaging educational environments and demonstrate their potential to transform outcomes for diverse learners. Assessment and design procedures tailored for ESL and visually impaired students focus on creating inclusive and effective learning experiences. For ESL learners, assessments often integrate multi channel methods combining visuals, audio, and interactive elements to enhance comprehension. Design strategies include pre-tests to gauge language proficiency, followed by multimedia interventions like AR-based vocabulary lessons, and post-tests to measure progress. For visually impaired students, assessments use tactile and auditory tools such as braille devices or audio-guided tasks to ensure accessibility. Procedures are carefully structured to reduce cognitive load, incorporating clear instructions, and segmented content for ease of understanding. These assessments not only evaluate learning, but also support skill building through adaptive and personalized approaches. By focusing on accessibility and engagement, these procedures empower learners to achieve meaningful educational outcomes. Implementing multimedia tools for ESL and visually impaired students presents several challenges. One major barrier is a lack of access to advanced technologies, particularly in under-resourced schools or regions with limited funding. Many institutions struggle to afford tools like augmented reality, virtual reality, and AI-driven systems, which hinders equitable adoption. Another challenge is the need for extensive educator training to effectively integrate these technologies into teaching practices. Without proper training, even the most advanced tools may fail to meet learner needs. For visually impaired students, designing materials with adequate tactile and auditory support requires specialized expertise, which can be a hurdle. Especially scaling these solutions to accommodate diverse languages and learning profiles for ESL students can be complex. Addressing these challenges requires strategic investment, interdisciplinary collaboration, and a focus on scalability and training to ensure every student benefits from these transformative technologies. Assessment and design procedures tailored for ESL and visually impaired students focus on focuses on creating inclusive and effective learning experiences. For ESL learners, assessments often integrate multi-channel methods combining visuals, audio, and interactive elements to enhance comprehension. Design strategies include pre-tests to gauge language proficiency, followed by multi followed by multimedia interventions like AR-based vocabulary lessons and post-tests to measure progress. For visually impaired students, assessments use tactile and auditory tools such as braille devices or audio-guided tasks. To ensure accessibility, procedures are carefully structured to reduce cognitive load, incorporating clear instructions and segmented content for ease of understanding. These assessments not only evaluate learning, but also support skill building through adaptive and personalized approaches. By focusing focusing on accessibility and engagement, these procedures empower learners to achieve meaningful educational outcomes. Addressing resource and training gaps is critical to successfully implementing multimedia tools for ESL and visually impaired students. Limited access to technology. Let's go back. All right. All right. Where are we at? Tailoring strategies for diverse learners, such as ESL and visually impaired students, requires a learner-centered approach that recognizes and addresses individual needs. For ESL learners, strategies should incorporate multi-channel methods combining visuals, audio, and interactive content. Tools like AR can make abstract language concepts tangible by linking vocabulary and real-world objects, while ebooks with bilingual support and audio narration enhance comprehension. Additionally, gaming-based approaches encourage collaboration and practical application of language skills in an engaging and supportive environment. The future of accessibility in education lies in advancing research and developing innovative technologies that cater to diverse learners. For ESL students, future tools could include AI driven language platforms capable of providing real time, context aware feedback in multiple languages, making language acquisition more intuitive and personalized. For visually impaired learners, innovations like enhanced tactile AR and VR systems, which combine auditory and haptic feedback, could transform how they interact with complex subjects such as math and science. Additionally, interdisciplinary research can focus on improving scalability, ensuring that these technologies are affordable and accessible to underfunded schools and communities. Collaborative efforts between educators, technologists, and policymakers will be vital to creating inclusive standards that guide the development of educational tools. Emerging innovations such as brain computer interfaces and advanced adaptive technologies hold the potential to make learning even more personalized and engaging. These advancements will not only break down barriers, but also empower students to thrive in diverse educational environments, paving the way for a more equitable future. Inclusive education is vital for meeting diverse needs of ESL and visually impaired students. And multimedia tools like AR, VR, ebooks, and AI driven platforms are transforming how we achieve this. By applying principles from the cognitive theory of multimedia learning, such as modality, coherence, and signaling, we can design tools that reduce cognitive overload and enhance learning experiences. Key takeaways include the importance of tailoring strategies to the individual learner needs, investing in scalable technologies, and prioritizing educator training to ensure effective implementation. Despite challenges like resource limitations and accessibility gaps, innovative approaches in gaming, adaptive assessments, and tactile tools offer promising solutions. By focusing on collaboration, research, and continuous innovation, we can create equitable, engaging, and effective learning environments that empower all students to succeed. Thank you for listening to my presentation.